Hello viewers, so you're welcome as you work out this maths problem within the shortest time possible. So let's start with the solution. So make sure you enjoy watching this video up to the end. So on our solution, so this one is the maths problem. We have 3 to the power of a, then multiply by 3 to the power of a is equals to 27. So the reason for this dot simply means multiplication. So now here is the formula for this. Now we all know that suppose we have m to the power of n, then multiply again by m to the power of n. So this one can also be written as m to the power of n plus n, simply because the multiplication now shall change to addition. So in that case now we shall have now m to the power of n plus n is 2:n. So I want us to express this value here into the form m to the power of 2n. So in that case now, when we have 3a multiplied by 3a, as you can see, so here 3a multiplied by 3a, now we shall now have 3 to the power of a plus a. So and our value for a plus a now becomes, so our answer is now 3 to the power of 2a. So that simply means that 3 to the power of a shall be equivalent to 27. So let's now rewrite it here and say that 3 here to the power of 2a is equals to 27. So now we are, as usual, now we are we are asked to solve for the value for a. So this one is now what we shall do. This 27 is a whole number, 3 is a base, and 2a is an index. Now, so assume now we have the log of m to the power of p. This one can also be written by having now p log m. So I want us to express 3 to the power of 2a into the form of p log m. So the reason is this: we want to change, or we want to introduce the log on both sides of the equation of 3 to the power of 2a, which is equals to 27. So that now means that now we shall have the log. So the log of 3 to the power of 2a is equals to the log of 27. So let's write it in the form of p log m. So in that case now we shall have now 2a log 3 is equals to the log of 27. So in this case now we want to remain with 2a on this other end. So we shall be forced to divide both sides by the log of 3, then also this side also by the log of 3. So that the log of 3 and the log of 3 shall cancel. So now we shall remain with 2a. So now 2a is equals to the log of 27 all over now the log of 3. So this does mean that we stop here. So let's now factorize the log of 27 all over the log of 3. So now we shall have 2a, which is equals to the log of 27 can also be written as the log of 3 multiplied by 9 all over now the log of 3. Reason 3 multiplied by 9 becomes 27. So we can also rewrite it by saying that 2a now is equals to, following the law of logs or logarithm, so now we shall have now the log of 3 plus the log of 9 all over the log of 3. So in this case, let's now divide both sides by the log of 3. So now we shall now say that 2a is equals to the log of 3 all over the log of 3, then plus now the log of 9 all over the log of 3. So we shall now say that 2a is equals to, so when we work out the log of 3 divided by the log of 3, we shall now have 1, then plus the log of 9 all over the log of 3. We can still go ahead and factorize the log of 9 all over the log of 3 by now saying that 2a is equals to 1 plus, so the log of 9 can also be written as the log of 3 then multiply by 3 all over the log of 3. So in this case now we shall now split and say that 2a is equals to 1 plus, so we can also rewrite it by having the log of 3 following the law of logarithm plus the log of 3 all over the log of 3. So in this case, so as we conclude, we shall have 2a is equals to 1 plus, so let's now divide both sides here by the log of 3. So 1 plus the log of 3 all over this, the log of 3, then plus this, the log of 3, all over here now the log of 3. So now we shall say that 2a is equals to 1 plus, so the log of 3 and the log of 3 shall cancel, plus 1 plus here now shall cancel, shall have 1. So now 2a is equals to 1 plus 1 plus 1 is equals to 3. So in order for us to remain with a on this other side, we shall divide both sides by 2, here also by 2. So that 2 and 2 shall cancel, so that our a shall now be equivalent to 1.5. So that now marks the correct answer. So if you really loved how we've solved this maths problem, please kindly subscribe to our channel.